Welcome students. Chapter number 3, Maths part 2, Circle, and today we are going to study touching circles and practice set 3.2. Now what is mean by touching circles? If two circles have only one common point, then that circles are called touching circles. Here are two circles, O with center O and with center O dash, and these two circles touch each other externally and they have a common point T. And here are two circles with centers O and O dash, and these circles touch each other internally and they have a common point T. Such circles are called touching circles. Now theorem of touching circles. If two circles touch each other, their point of contact lies on the line joining the center. If two circles touch each other, their point of contact lies on the line joining their centers. This point of contact T lies on the line O dash. O dash is a line joining their centers. Here also the point of contact T lies on the line O dash, which is the line joining the centers of the circles. If two circles touch each other externally, then the distance between their centers, that is the distance of O dash, is equal to sum of their radii, that is R1 plus R2. If two circles touch each other internally, then the distance between their centers, that is the distance of O dash, is equal to the difference of their radii, that is R1 minus R2. Practice set 3.2. Question number 1. Two circles having radii 3.5 cm and 4.8 cm touch each other internally. Find the distance between their centers. These two circles touch internally and we have to find the distance between their centers O dash. Let R1 is equal to 4.8 cm, R2 is equal to 3.5 cm. Circles touch each other internally, therefore distance between their centers is equal to R1 minus R2 is equal to 4.8 minus 3.5 is equal to 1.3 centimeter. So distance between their centers, that is O dash, is 1.3 centimeter. Question number 2. Two circles of radii 5.5 centimeter and 4.2 centimeter touch each other externally. Find the distance between the centers. Here also let R1 is equal to 5.5 centimeter, R2 is equal to 4.2 centimeter. Circles touch each other externally, therefore distance between their centers is equal to R1 plus R2. Circles touch externally. Distance between their centers O dash is equal to R1 plus R2 is equal to 5.5 plus 4.2 is equal to 9.7 centimeter. 9.7 centimeter. Question number 3. If radii of two circles are 4 centimeter and 2.8 centimeter, draw figure of this circle touching each other externally. Number 2, internally. Take distance of 4 centimeter in a compass and draw circle of radius 4 centimeter, and the center of that circle is O. Now take 2.8 centimeter distance in a compass from point T. Take the point O dash at 2.8 centimeter and draw another circle of radius 2.8 centimeter with center O dash. These are externally touching circles. Now internally touching circles. Take 4 centimeter distance in a compass and draw the circle of radius 4 centimeter with center O. Now take the distance 2.8 centimeter in a compass and from point T take O dash at 2.8 centimeter. From O dash draw the another circle, that is internally touching circles. Question number 4. In the figure, circles with centers P and Q touch each other at point R. A line passing through R meets the circle at A and B respectively. Then prove that number 1, segment AP parallel to segment BQ. These are two circles with center P and Q and touch these circles at point R, and the line this passing through the point R touches the circles at A and B. Now we have to find segment AP parallel to segment BQ. Now consider triangle APR. In triangle APR, segment AP is equal to segment PR. Segment AP congruent segment PR. Radii of a same circle. Therefore, angle PAR, this angle and this angle are equal. Angle PAR congruent angle PRA. Isosceles triangle theorem. Let this is the equation number 1. Now in triangle RQB, consider triangle RQB. In triangle RQB, now let's see, these two angles are vertically opposite angles. Therefore, angle PRA congruent angle PRA congruent angle QRB vertically opposite angles. This is equation number 2. Now in triangle RQB, segment RQ congruent segment QB. Radii of same circle. Segment RQ congruent segment QB. Radii of a same circle. Therefore, angle QRB congruent angle QBR isosceles triangle. Theorem. This is equation number 3. So this angle is equal to this angle. This angle is equal to this angle, and this angle is equal to this angle. Therefore, these two angles are equal. Therefore, angle PAR congruent angle QBR. This is from equations 1, 2 and 3. But angle PAR means angle PAB. That is angle PAB congruent angle. QBR means QBA. Angle QBA. Reason is A dash R dash B. A dash R dash B. But now see, these two angles are congruent. If AP parallel to BQ and AB transversal, then these two angles are alternate angles. As these two angles are congruent, segment AP parallel segment BQ. Therefore, we write segment AP parallel segment BQ. Reason is alternate angle test. Now number 2. We have to show triangle APR similar triangle RQB. In triangle APR and triangle RQB, these two angles are congruent. So angle APR congruent angle RQB. AP parallel to BQ and PQ transversal. Therefore, these two angles are alternate angles. Reason is alternate angles. Now, this angle and this angle are congruent. So, angle PAR congruent angle PAR congruent angle QRB. Reason is from equation 1 and 2. In equation 1, these two angles are congruent, and in equation 2, these two angles are vertically opposite angles are congruent. Therefore, this angle and this angle are congruent. Reason is from equations 1 and 2. Therefore, triangle APR similar triangle RQB. Two angles are congruent. Then what is test? A test of similarity. A test of similarity. Now find RQB. RQB, this angle. If angle PAR is equal to 35 degree. Now angle PAR is equal to 35 degree given in triangle RQB. In this triangle, angle PAR is equal to angle QRB is equal to angle QBR. From equations 1, 2, 3, these two angles are equal, and this angle is equal to this angle. This angle is 35 degree, therefore these two angles are 35 degree. Therefore angle QRB plus angle QBR plus angle RQB is equal to 180 degree. Sum of all angles of triangle is 180 degree. Therefore these angles are 35 degree, QRB is 35 degree plus QBR 35 degree plus angle RQB is equal to 180 degree. 35 degree plus 35 degree, 70 degree plus angle RQB is equal to 180 degree. Therefore angle RQB is equal to 180 degree minus 70 degree. Therefore angle RQB is equal to 110 degree. So this is solution of example number 4. Question number 5. In the figure, circles with centers A and B. Circles with centers A and B touch each other at point E. Line L, this line L is a common tangent which touches the circles at C and D respectively. Find the length of CD. We have to find the length of CD if the radii of the circle are 4 cm and 6 cm. Now construction. Draw segment CA, segment BD and segment AB. Draw perpendicular AM to BD. Draw segment AM perpendicular to segment BD. Now let's solve this example. A dash E dash B. This is a center of the smaller circle. B is the center of bigger circle, and circle touch at point E. Therefore these 3 points are along the line joining their centers, and this is the theorem of touching circles. Theorem of touching circles. Now we have given radius of this circle 4 cm and radius of this circle 6 cm. Therefore AC is equal to AE is equal to 4 cm and BE is equal to BD is equal to 4 cm. So we write AC is equal to AE is equal to 4 cm and BD is equal to BE is equal to 6 cm. Radii of a same circle. Radii of same circle. Therefore we get the value of AB. Therefore AB is equal to AE plus BE is equal to 4 plus 6 is equal to 10 cm. So this value we get 10 cm. Now construction is a AM perpendicular BD. Therefore this angle will be 90 degree and this angle ACD is a 90 degree. This is due to the tangent theorem. Line L is a tangent and AC is a radius. So angle between tangent and radius is 90 degree. This angle will be 90 degree. This angle will also 90 degree because here BD is a radius and L is a tangent. So according to tangent theorem, this angle is also 90 degree. The angle between tangent and radius is 90 degree. Therefore this quadrilateral quadrilateral ACDM is a rectangle. So we write in quadrilateral ACDM, angle ACD is equal to angle ACD is equal to angle BDC is equal to 90 degree. Reason is a tangent theorem. Angle AMD is equal to 90 degree. The reason is construction. Therefore, quadrilateral ACDM is rectangle. Its three angles are 90 degree. These three angles are 90 degree. Therefore, this angle is also 90 degree. Therefore, this quadrilateral is rectangle. We know that opposite sides of quadrilateral are equal. This distance is a 4 centimeter. Therefore, the distance also 4 centimeter. Therefore, AC is equal to MD is equal to 4 centimeter. Reason is opposite sides of rectangle, opposite sides of rectangle. Now let's find the distance BM. BD is a 6 centimeter and now DM is a 4 centimeter. Therefore, BM will be 2 centimeter. So here BD is equal to BM plus MD. Reason is D dash M dash B. Therefore, we have to find BM. BM is equal to BD minus MD is equal to BD is a 6 centimeter. 6 minus MD is a 4 is equal to 2 centimeter. Therefore, we get here BM is equal to 2 centimeter. BM is equal to 2 centimeter. This distance we get 2 centimeter. Now consider triangle ABM. In this triangle, angle AMB, this angle is a 90 degree. Therefore, we can apply the Pythagoras theorem for this triangle in order to find the value of AM. So, write in triangle AMB, angle AMB is equal to 90 degree. This is reason is a construction. Therefore, we can write a Pythagoras theorem for this triangle. So, the side opposite to the 90 degree is hypotenuse. So, AB square is equal to, this is hypotenuse, AM square plus BM square. Reason is Pythagoras theorem. Pythagoras theorem. Now we have to find the value of AM. Therefore, AM square is equal to AB square minus BM square. Therefore, AM square is equal to value of AB is a 10, 10 square, and value of BM is a 2 minus 2 square, that is 100 minus 4 is equal to 96. This 96 can be written as 16 into 6. Therefore, AM is equal to square root of 16 into 6, taking square root on both sides. Taking square root on both sides. Therefore, AM is equal to square root of 16 is a 4 root 6 centimeter. But AM is equal to CD, opposite sides of rectangle. Opposite sides of rectangle. Therefore, CD is equal to 4 root 6 centimeter. Thus, we get value of a CD. Students, thus we have completed the practice set 3.2 today.